In this short video, we'll learn about the mean value theorem. The theorem says, if a function f of x is continuous on a closed interval from a to b and differentiable on an open interval from a to b, then you can find a point on the open interval from a to b that satisfies the derivative at that point c equals to f of b minus f of a divided by b minus a. And you can notice that this formula here is the slope formula of a secant line that goes through the two endpoints of the interval a f of a and b f of b. Now, if we look at the graph of the functions on the right side here, we can see that the graph is continuous from a to b. In this case, a equals to 0 and b equals to 10. And clearly, the graph is differentiable on the same interval. So first, we want to find the secant line that goes through the two endpoints, a f of a and b f of b, right? And you can look through the interval to find a point at which the slope of the tangent line at that point will be the same as the slope of the secant line, which is the green line. So the red line and the green line are parallel, which means they have the same slopes. We call this is point C. So there exists a point C, right? You guarantee to have this point C on the interval from a to b, such that the derivative at c equals to the slope of the secant line from a to b. But c here is not unique. You can find in some examples, in some functions, you can find multiple points that satisfy these conditions. And in this case, you can find another point here, in which the slope of the tangent line is the same as the slope of the secant line. Right. So this is the mean value theorem. People use this theorem in order to find the existence of a point at which you have the same, the slope of the tangent line is the same as the slope of the secant line. And one of the special cases of the mean value theorem is when f of a equals to f of b. So if you look at the formula, if f of a equals to f of b, then c is a critical point. This is because, f prime of c will be equal to 0. What does that mean? That means if you have the mean value theorem, if you have all the conditions that satisfy for the mean value theorem, and if you have another extra conditions, which is f of a equals to f of b, then you guarantee to have a local extremum, which means you guarantee to have at least either one local minimum or one local maximum on the interval from a to b. So this special case here is the Rolle's theorem. All right, now we can summarize this short lecture. So the mean value theorem needs to have two conditions. A function needs to be continuous on a closed interval from a to b and differentiable on an open interval from a to b. And then in order to use the Rolle's theorem, you need a third condition, which is f of a equals to f of b. So the mean value theorem guarantees to have a point on the interval such that the derivative at the point will equals to the slope of the secant line that goes through a and b. The Rolle's theorem guarantees that you will have at least one local extremum, which could be either local minimum or a local maximum on the interval from a to b.